Hello, Math 3 students. Mr. Eicher here again. This is part of a lesson 9.2 about arithmetic sequences. In this lesson, we'll learn about sigma notation. So main thing I want you to know about sigma notation is how to read the notation, what it's asking you to do, and how to evaluate sums of arithmetic series with sigma notation. Now, sigma notation is pretty important. This lesson is just a brief introduction to sigma notation, but in later math classes, particularly Math 4, and even more so calculus, sigma notation makes a really big part of those courses. So let's get started. We got, these are the notes from 9.2, so if you don't have those, grab those. But I'd like to talk about sigma notation in number 13, 14, 15. So sigma notation is a concise notation for writing series. For example, the series 3 plus 6 plus 9 plus 12 plus ... plus 30 can be expressed in this notation. So let's talk about this notation, known as sigma notation. So what this notation says to do, this letter right here, this is known as sigma. It's a Greek letter, capital Greek letter sigma. And it stands for a sum. This n equals 1, that's your first term. So, and then your last term, it goes until the 10th term. Now, even though you don't see 2, 3, 4, 5, 6, 7, 8, 9, basically you're starting at 1. That's your lower bound. There's another word for that, or term for that. And then 10 is your upper bound. And then this quantity right here, 3n, tells you how to generate the next term. So if we start with the first term, we plug 1 in, 3 times n is 3. And then we're going to plug in 2, right? We're going to plug in numbers all the way until we get to 10. So if you plug in 2 to this, that would be 3 times 2, 3 times 3, 3 times 4, 3 times 5, 3 times 6, 3 times 7, 3 times 8, 3 times 9, and then finally 3 times 10. So we took this function 3 and we multiplied by numbers from 1 all the way to 10. And what this notation is doing, it's representing this long string. It doesn't tell you how to calculate that. We'll talk about how to do that in a second. But it's basically a concise way of writing this long string. So you imagine mathematicians, they might be working with very long strings of expressions. So to write a concise, right? To write a concise notation, that's what sigma notation is doing. We read this as the sum of 3n as n goes from 1 to 10. So let's look at number 13. First, let's just write this out, and then we'll talk about using the formulas we've talked about in this section, how we'd be able to evaluate this. So we want to find the sum of this function 2 minus 3n, and we're starting at 1 and we're ending at 4. So I'll write it out like this, just so you could see. So the first term, when n is 1, the first term, you'd plug 1 into this, and that'd be 2 minus 3 times 1. And that would be negative 1. The second term is 2 minus 3 times 2, and that would be negative 4. And the third term would be 2 times 3 times 3, and that's negative 7. And then the fourth term, and this is the last term. This is the last term because the upper bound, the highest number, is 4. So the last term would be 2 minus 3 times 4. 2 minus 12 is negative 10. So what we're asked to do is find the sum of those terms. Now, if we're going to write them all out like that, we could just add. So negative 22, is that right? Yeah, that looks right. So the sum, this sigma notation would equal negative 22. Now, what's an approach that we could use if we didn't want to have to write all the numbers out? Well, from earlier lesson, we have this formula, the sum of these four terms would be, let me write the general formula first, actually, just to review that a little bit. So the sum of n terms is n over 2, the first term plus the last term. So the sum of these four terms would be, well, we have four terms over 2. The first term we had was negative 1, and the last term that we had was negative 10. So we'd have negative 1 plus negative 10. So that would be 2 times negative 11, and that would be negative 22. And that's what we got by adding the others. Now you might ask, why would you choose to do it this way when this way was pretty efficient? Well, this way on the left here, this was only efficient because we only had four terms. Imagine if you had 100. You don't want to have to write out all the terms. But again, the point of this lesson is to get you used to how to read this sigma notation and what all the different numbers and symbols mean. So let's go over to number 14. Here's an example of, you really don't want to write out all the terms. We'll write out a few terms, but notice there's going to be 200 terms. That's way too many to write, but we'll write a couple. So let's say a sub 1, the first term, plug 1 in. So 1 plus 2. First term's 3. The second term would be 2 plus 2, so 4. The next term would be 3 plus 2 is 5. And this is going to keep going on and on. We don't really want to do that. But we do need the last term. The 200th term would be, plug 200 in, 200 plus 2, and that would be 202. So we need to add all these up. We need to add all these numbers up, but it's not really going to work. But let's just take the first and the last terms. In our general formula, n over 2, a sub 1 plus a sub n. What is our n? How many terms do we have? Well, we're going from 1 to 200. So that's 200 terms. Divided by 2. Our first term's 3, that I've highlighted there. And our last term's 202. So that would give us 100 times 205. And multiplying that would be 205 with 2 zeros. So our sum would be 20,500. So this equals 20,500. So that's an approach. Rather than just simply adding all the numbers, that would take a long time to add all the numbers that we were trying to do on the left, but using this arithmetic series formula. Really helpful. The last example is one that students often struggle with, mainly because it doesn't start at 1, it starts at 19. So let's find the 19th term, a sub 19. That would be 5 times 19 minus 3. And there's not too many terms, so let's just write out the other ones. 5 times 20 minus 3. 5 times 21 minus 3. 5 times 22 minus 3. And finally, the last term, the upper term here, is 5 times 23 minus 3. So 5 times 19 minus 3 is 92. 100 minus 3 is 97. 102, I believe. 107, 112. So here are our terms. Now, technically, you could do this since there's not that many terms. You could just add these. and then get your calculator out and add them up. However, I'd like to show you a different approach with this formula like we're using on the other examples. N over 2, a sub 1 plus a sub n. How many terms do we have? This is where students struggle. How many terms? Just looking at these numbers, you might think that there's only 4. Question mark, question mark. Because if you subtract 23 minus 19, you get 4. But when we actually wrote them out, look how many we have. Look at that. Look at that. We have 5. So you have to be really careful. It's not just 23 minus 19 to get 4 terms. It's actually 5 terms. If you remember this example, we said it's pretty clear, right? There's 200 terms. But 200 minus 1 is 199. And that's not the number of terms. It's 200. So on this example, if you're going to try to subtract, you always have to remember to add 1. So 23 minus 19 is 4, but it's always 1 more than that, so 5 terms. And you can see I wrote out all 5 terms. So our sum of these 5 terms would be there are 5 terms over 2. The first term is 92, and the last term is 112. So we have 92 plus 112 times 5 over 2 is 510. So this sigma notation equals 510 is the sum. So that's using sigma notation, a concise way of writing a series. And I am going to stop sharing. Aha! So thanks for watching this video. If you have any questions, feel free to message me or your teacher. And have a great day. If you like this video, if you like sigma notation, yeah, give me a thumbs up at the bottom there. That'd be nice. See you later.